everyone, and warm welcome to Life Cycle Talks. It's a series of talks presenting the research front to keep you up to date with the science and application of the life cycle perspective. Today's Life Cycle Talk is How can water footprint support a sustainable future? Where we will learn the challenges in communicating and using water-related information to inform individual and societal decision-making. My name is Maria Rydberg, and I'm happy to welcome our guest for today, Martyn Futter, who's a senior lecturer at Swedish University of Agricultural Sciences. Before we start the actual talk, I want to give you some practical information. All Life Cycle Talks will be published and made available on Swedish Life Cycle Center YouTube channel after this live event has ended. The raise hand function will not be used in Life Cycle Talks, but feel free to submit your questions using the Q&A function that you can find in your Zoom window. And we will select a few to address during the Q&A session after Martyn's presentation. But I will actually start with a warm-up question for you, Martyn. I am a bit curious. What motivated you to begin exploring this area of research?
Yeah, I first got interested in this about 15 years ago when I heard some statements about water and about forests that I initially found very confusing. And what I'd like to try and do is maybe unpack them a little bit throughout my presentation. I've been working with water communication and life cycle questions for about 15 years now, mostly in my teaching, more and more in my work with stakeholders and society. And when I'd started preparing this presentation, I was making something that I was trying to have very rigorous and very academic. And I then looked at the information I got from the Life Cycle Center about how I ought to prepare. And the last slide was this little guy, and he told me to have fun with it. So what I've done is I've kind of changed the presentation around quite a lot, and I want to share with you a journey I've been on for understanding water and how we maybe think about water and how we perhaps communicate it. And it started when I came to Sweden about 15 years ago to work on forest water questions. Forests in Sweden, they are managed. They're semi-natural, they're rain-fed. And shortly after I got here, we were starting to hear about carbon footprints and getting ways to think about our impact on the environment. And about this time, there was a tool developed called the water footprint, which published a number of descriptions of our impacts on the environment. So one of the things they said was that producing one box of paper takes or consumes 5,000 liters of water. So they were saying that there's a human appropriation of 5,000 liters of water to produce one block of paper. That comes out about 10 liters of water that we have appropriated, taken out of nature, consumed to make a sheet of paper. And I found this confusing, and well, given that I was working with the forest sector, if I have to put my cards on the table, I found this a bit of a challenge and a bit of a threat. How do we address this, and what does it mean? So we started out being academics, writing a scientific paper about forest hydrology. And we thought, well, we're never going to get this published. It's just basic hydrology, that there's a balance in the water up and the water down in the forest, and that it is natural processes. And well, we did get it published, and we had a number of discussions and moved forward. But what I'd like to do now is I'd like to maybe step back a bit from this rather specific question of forests and water and trees in Sweden and look at broader water questions. And this is, I think this really sums up why water is challenging. I wish I'd come up with the quote myself, but I didn't. It was Charles Iceland with an NGO. And well, starting with too much. This is a picture from north of where I live in Uppsala. Beginning of this year, there was flooding, which prevented planting in the fields, and the flooding came in the fall, so it destroyed the previous year's crop. This was last summer, a bit south of me. It was too dry and the crops died. And if I can kind of highlight the food production aspect throughout this quote, well, this is the too dirty aspect that food production is an inherently polluting activity, but it's a critical activity. And I think that it's also an activity where we can our decisions, but our purchasing decisions can move towards a better environment. And I think also as professionals, we can help to move the dialogue forward. So with that bit of background, I'd like to just switch to thinking about the words we use to describe the way that we as a society appropriate or incorporate water into the things we require. And one of the pairs of words I'd like you to think about is use versus consume. The panel on the picture on the left is a little hydroelectric plant in Austria, run-of-the-river plant, where it uses water to generate electricity. That water is returned to the river, and somebody else can do something with that water further downstream, be it a fish, be it a person, whatever. Put that against consumption. If I consume something, the next person or it's not available for anyone else. So I'd argue that, say, if I put water into a cement mixer, I'm consuming that water and making cement. It's not available for someone else. So that's an important question. And well, with forests, the evaporated water, I'd argue it's used because it can fall as rainfall elsewhere. And that maybe comes to the next pair of words, renewable and finite. Water is a challenge as it's maybe the only resource that is both renewable and finite, or can be conceptualized as both. Rainfall, it's largely renewable. On the other side of the picture, this is um, I guess it's the Ogallala Aquifer in the southern U.S. It's groundwater fed. It's mining a finite resource. So thinking about the words we use to describe, and finally, responsible versus sustainable. I realize I'm talking in a series of presentations about moving towards a sustainable future, and I find that it's almost an unachievable goal, I feel sometimes, but I do feel that it's possible to act in a responsible manner, and that possible to make progress that way. So I'd throw it out to all of you. Which is a better word, responsible or sustainable? But with that, I think I've said something about why the words matter. And now the next thing I'd wanted to talk about is why the science matters. And with thinking about the science, I just want to unpack hydrology a little bit, where I've spent my whole academic career. So hydrology is the science of water. And this picture here is pretty much the key of hydrology for food production, for wood production, really for life. And the key parts of this is plants have on their leaves lots and lots of little holes called stomata, and they take in CO2 through those holes to fix carbon for food or wood or what have you, and they put out water. So there's an explicit trade-off that if we're going to have any sort of carbon fixed for whatever purpose, we need to trade water for that. And thinking about where all the water is, there's a lot going on in this picture. But what I'd like you to do, if you can, is just try and look for some of the very small arrows that are on the green part of the picture. And these show the water cycles for photosynthesis, which is food production, and forest production. Relatively speaking, they're tiny to all the water on the planet, but they're absolutely critical for us. And if I then back out sort of to the mesoscale and think about, well, how does this actually play out in terms of where rainfall ends up and what rainfall does? Thinking about R down 100% of all the rainfall, 15 to 30% is T up. T is the transpiration. That's I guess I could call it trade-off. It's when the plant trades CO2 for water. So that's sort of the productive part of the water return. E is evaporation, just returns to the atmosphere to then fall as rain somewhere else. and R is runoff. So to replenish rivers, restore groundwater, what have you. So just sort of keep this in mind that of the rainfall coming in, about half, maybe three quarters returns to the atmosphere and some of it runs off. And of that amount that returns, some contributes to carbon fixation, which contributes to food production. Now, where this water falls and where the food is produced, that's quite important. And I think it's important for us in our decision making about responsible consumption. That ideally we would be consuming food that's either not making a huge water stress or produced in parts of the world that are not water stressed. And this was the idea behind the virtual water concept. And it's been operationalized in a number of infographics. I especially like this one, as what it does is it shows the transpiration and evaporation footprint of various kinds of food items, and it sort of puts them on a common currency. And I can start to think about the water impact of my consumption decisions. So starting to move towards something that I, as a consumer, can use, and that hopefully is based on robust science. This sort of virtual water concept can be further operationalized into a footprint concept. Carbon footprint, I think, was the first mainstream one. And I think it got us all thinking about our climate footprint. As an academic, I find it frustrating because there's so many different ways of formulating a carbon footprint. But big picture, the footprint's a good idea. It's a simplified metric. It's a guide. It lets all of us have a bit more information. And this one I have I'm ongoing challenges with, because I'd say it seeks to use a life cycle perspective, and if I'm being a little bit um, skeptical or cynical, I'd say, well, it's perspective is not the same as actually being truly in a life cycle framework. So I think it's a goal of the footprints, but they're very different from life cycle analysis. And finally, a sort of a warning that footprints run a risk of expanding to the point of being possibly confusing instead of useful, but hopefully having some good science behind them and some understanding of the choice of words will help us to make better decisions. And the water footprint certainly moved a bit in that direction, and I think is moving in that direction. And one of the things I think they do very well is they tries to give us an idea of where the water actually goes. So the green water for plant production, that's the big part. That's the transpiration, that's the evapotranspiration, that's the trading water. The blue water, if it uses irrigation or takes groundwater, and then gray water, how much water is polluted to get at the production of something we want or we need. So it's a little bit of a way of starting to think about the question of too much, too little, too dirty, in a way that maybe operationalizes and simplifies and maybe gives us a way of having some sort of a dialogue or an increased awareness. Now, I sort of then step back and reflect a little bit on this and present a bit of a SWOT analysis of the footprint concept. This is adapted from an Alvarez paper, which I don't remember if it's on the reading list, but I do think it was a very useful one. And some of the strengths of the footprint approach are they are easy to understand and to communicate. They are easy to implement, but that's also perhaps some of the problems with them. They can have a limited accuracy. They're not really connected to LCA. That's getting better, but they really do something quite different than life cycle analysis. They're a consumer communication product. They're more like a stamp of approval than a robust analysis. Having multiple definitions, I think, can lead to confusion and perhaps limited acceptance. And I struggled a bit with whether or not to include incorrect science. I think it's fair to include incomplete, and if I'm honest, I'd say incorrect is a little bit in the eye of the beholder, but I'd say one does need to dig into what the scientific basis is of any footprint and whether one finds it credible or not. Moving from the weaknesses to the opportunities, the vast number of footprints is, it is a weakness, but it's also an opportunity. Is there's lots of methods, there's lots of databases, there's lots of publications, there's lots of interest, and because they're easy to understand and communicate, they're attractive both to the public, to investors. The idea of having this kind of indicator-based thing is buried also in the Green Deal. And it does offer some sort of possibility for independent audit, which I think can make the whole process a little bit more robust. But having said that, there's very subjective boundaries. There's so many methods it can be hard to communicate. And it really is difficult to scale from an individual product level to a sort of a whole process or a whole business level. It can be done, but it's not straightforward, and footprints aren't really the tool for that. So I think one of the things that happened in the past few years is a recognition that footprints serve one purpose and LCA serves a different purpose. But if I can sort of start to move towards trying to wrap this all up, this is a problem that I've confronted in my whole professional career thinking about water. I wish I'd had such an elegant way of phrasing it. Communication tools like footprints can help for more informed decision making, which can lead to more responsible actions, perhaps more sustainable actions. Really, the words we use to describe a situation matter. With the water question, it's a lot, I think, to do with what constitutes human appropriation and whether we're actually taking water away from an ecosystem and preventing it being used for more natural processes. Thinking about science and thinking about scale is really important. And I think it's to find the red thread between uh, academic science and what's actually usable for decision making. And I put it to all of you that that's a lot harder than it looks, or either that or I'm just not very good at it. But finally, then, if I can summarize, words matter, and the science matters. And most importantly, we matter. And with that, I'd very much like to thank the organizers, and I'd like to thank all of you for coming to listen to this. And I guess I hand it back over to you now, do I, Maria? Okay.
Yes.
And I stop sharing and you take over.
Yes. Thank you so much, Martyn. It was a really nice presentation. Now we will have time for questions, and I will start with a question from my side, and then we will choose a few from the Q&A as well. But starting off with one from my side. So, what do you see as the biggest challenge with environmental communication about water?
I think it's having robust science underneath it, as I think that it is. Our big concern where I came in on this was that people would get a misleading impression of the environmental impacts of Nordic forestry as just from using this sort of footprint water consumption approach. It would look a lot better to be using plantation forestry of exotic species in South America. And I just, my gut feeling is that a semi-natural system is more environmentally friendly than an exotic plantation system. And I'm concerned that if the science isn't robust, we as consumers could get the wrong message and make ultimately poor decisions.
Do you see any convergence between footprint indicators, LCA, and the ISO standards?
Yeah, I think that I'm really encouraged by the way the process is evolving as I would say 10 years ago or so, the footprint community became aware of the LCA community, and the footprint community said, "Oh, we can do everything in an LCA. We can do everything at the sort of the very detailed business level, as well as the environmental communication." And at this time, it may be unfair, and maybe some people in the audience will take me to task for this, but my impression was the LCA community would say, no, no, we can do everything. We can do the really robust, auditable, high quality, detailed work, and we can do environmental communication. And at the same time, the ISO 14046 standard was developing, which I think took a lot of the best ideas in the environmental communication of the water footprint, and it put it into a format that could be used by LCA, could be used in a more kind of rigorous and structured process. So right now, I think there is some good convergence, some good dialogue, and an increasing awareness that different tools are better for different purposes.
Well, that's a good good thing that things are happening in the right direction. But looking at the difference between, or the difference and between carbon and water, does water offer any lessons for carbon or other types of like non-standard LCAs?
I think it does. And I would say it offers the lessons at perhaps a fairly conceptual level. And it has to do with our choice of words and how the words we use to describe something, how they really matter. I think there are a lot bigger challenges in making the science fit for purpose for use in an LCA. I think it's hard with water and carbon, and I would argue also with eutrophication indicators. It's infinitely more difficult with social sciences, as in my opinion, social sciences are infinitely more difficult than natural sciences. So there are possibly some conceptual lessons. I think that there's maybe not specifics that I can see right now, but I think it does offer some ideas of the challenges as LCA expands in scope from sort of the legacy of what happens inside the factory gates to sort of full cradle to grave assessments.
It's really, really nice. And you talked about the words here, and I think this question from the Q&A is a bit connected to that. The distinction between water use and consumption is important and tricky. I assume that the water fed into a cement blender evaporates and returns to the atmosphere as the cement dries. Is that correct?
Some
Is
fraction of it would.
is
That is correct. Yes.
Yeah.
So some
Uh,
fraction of it will, but some fraction is incorporated in the product. So that's a good point, and maybe I need to rethink that when I do this presentation next. Thank you, whoever posed that.
And then there was a follow-up question. Is then perhaps cement blending also water use rather than water consumption? And you kind of already answered that, maybe.
Yeah, but maybe I could unpack it a little bit more as I was involved in the ISO 14046 process, pushing to have use included instead of consume. And I think what was eventually decided was that if water is moved outside the system boundaries in whatever way, this counts as consumption. So if the water remains within the system boundaries, this can be water use and possibility of reuse. But if the water travels outside the system boundaries, for example, with transpiration from a growing forest, this is treated as consumption. So I think the words matter, the system boundaries matter.
Huh? I think this question actually is in the same area. So, what kind of water use slash consumption should be reported in LCA papers, in your opinion?
I would say that if it can be reported in a consistent manner with the ISO 14046, but I would also say it comes a lot to having clearly specified system boundaries, and then trying to have a full accounting within those boundaries. This is certainly system boundaries has been a challenge with any discussion I've had about carbon LCA, and I believe it will be common to water. So I would say the important thing is that whatever is being presented in an analysis should be it shouldn't be I'm trying to look for the right words for this, but it should be presented in a format that whoever is going to be consuming this analysis is comfortable with.
All right, that sounds reasonable. And you established that water footprint is different from water LCA, and I agree. Do you have experience with water LCA? Would you recommend a method for performing water LCA?
I have to admit, I am more of a consumer of LCA than a producer of LCA. I'm involved in some LCA projects now, but I would not describe myself as an LCA expert. I don't know if this is something that I should have mentioned before we started this process, but if I'm honest, I think there's going to be many people in the audience who are far more expert on this than I am.
But amongst the different water footprint methods proposed within LCA, how well do you think the AWARE captures the hydrological aspects?
If I was going to do the academic lecture, most of my academic lecture is about the AWARE method, saying, I think this is the way forward. It's a good balance between scientific robustness, availability of data, and simplicity of communication. So I'm a big fan of the AWARE method, but it was, well, the little creature told me to have fun. I'll blame him.
That's fine, I think. It's nice. It's good to have fun. I have one final question. Do you think individual choices really matter when it comes to water, or is it mostly about systems and policy?
I think individual choices really matter, as ultimately the people who are deciding systems and policy are also individuals. Maybe it's not us who are making the decisions, but I believe that we can all play a role, and maybe it's not a big role, but I think if we don't play it, if we don't take the role ourselves, I do not see it coming from anywhere else. So I would say we as individuals, we must feel that we have an ability to act, and that we can act in a way that we believe will contribute to act more responsibly, to contribute to greater sustainability. And it can feel like how's anything ever going to change? But I really think we've got to believe that our actions can make a difference, even if it is just a tiny one.
Thank you so much. Now I will wrap it up. Thank you very much, Martyn, for your presentation and for answering all of the questions.
Thank you.
And if you want to know more about water footprint, these 4 publications is a good start. Links to all of these articles can be found on our calendar at lifecyclecenter.se. You just click on calendar in the main menu of the page and then go to today's date, and you will find all the information that you need. The Life Cycle Talks are published by the Innovation Cluster for the Life Cycle Perspective and the Swedish Life Cycle Center. I want to thank you all for listening, and next talk will be in June. So please follow Swedish Life Cycle Center on LinkedIn and feel free to subscribe to our newsletter to keep up to date with life cycle talks and our other events and information. And on this slide, you can also see Martyn's email address if you had a question that we didn't have time to answer. And with that said, thank you everybody. Looking forward to seeing you again at our Life Cycle Talks.